Hello and welcome to this lesson on mutually exclusive events. Now I did not give you a note sheet provided with this lesson because tomorrow's assignment starts off with some very basic mutually exclusive problems, but I want you to get a sense for what mutually exclusive is before you get to class tomorrow. So feel free to take any notes that you want to on a separate sheet of paper. So let's look at what the definition of mutually exclusive is. Okay? Two events are said to be mutually exclusive if they have no elements in common. Basically what that means is if you have a Venn diagram, you have event A, and you have event B that have nothing in common. They do not intersect. Okay? So that's what mutually exclusive means. So for example, okay, say the probability of A is 0.6 and the probability of B is 0.2, and I say A and B are mutually exclusive, we can set up a Venn diagram as such. We can have event A and B. They do not intersect because they're given to be mutually exclusive. 0.6 is inside of A, 0.2 is inside of B, and the remaining 0.2, that's neither of them. So if I ask you to find the union of A and B, all you have to do is just add up the probability of A and the probability of B. You don't have to worry about any intersections. That would be 0.8. If I said find the probability of the intersection of A and B, well, because there is absolutely no intersection between them, what you would say is that it would be 0. Okay? There is no possibility of having any kind of intersection with mutually exclusive elements. And if I were to say something like, what's the probability that you're not in A intersected with B? Well, that's just going to be the probability of B. If you look at the Venn diagram, anywhere that's not in A is a 0.2, 0.2. Intersection with B is the 0.2 inside the diagram right here. So it's just going to be 0.2. Okay, so that's a nice little lesson, a brief lesson on what mutually exclusive is. No elements in common. Now I also want to take some time to point out the difference in the comparison between mutually exclusive events and independent events. Because both of these terms sound very similar to each other to me, and they probably do to you as well. Mutually exclusive, however, as we just mentioned, has nothing in common. Okay, that's what that means. They have no elements in common. This is mutually exclusive. Alright, and we have independent events, as we saw in the past. They have an intersection, for sure. Independent events. But what the definition of independent was is that the probability of one occurring has no effect on the probability of another occurring. Okay? But there is some kind of intersection. So remember the formula for that was the probability of A and B divided by the probability of B is equal to the probability of A. The probability of their intersection divided by the probability of B just is equal to the probability of A. Okay? Which is also given as something like probability of A given B is equal to the probability of A. Let's switch the letters and it still works the same. Okay. But as you notice with mutually exclusive, the probability of A and B is 0. So there's a clear difference between these two things. And make sure you note that. Okay. Thank you for watching, and tomorrow in class you will have the assignments to work on.